In an interview, well-known American astrophysicist Neil deGrasse Tyson forewarned that humans may discover things in space that will test our comprehension. Amazingly, Voyager 1 has found 775 undiscovered objects passing through space. Even after 45 years in operation, scientists are constantly in awe of what Voyager 1 finds every day. Neil deGrasse Tyson said, "And once you're outside the zone, you're basically roaming through interstellar space at that point, so it's not obvious if much will change for you. It will be intriguing if we discover something other than nothing." Neil deGrasse Tyson's remarks serve as a reminder that despite Voyager 1's August 2012 entry into interstellar space, almost little is known about it at this time. Anything that we discover there will be shocking and unknown. We are receiving measurement data from an enigmatic sphere for the first time. The majority of the cosmos is made up of the interstellar medium. We can hardly begin to comprehend the size of the voids that exist between the stars. Voyager 1's initial data transmission from this region was a first, despite the fact that scientists have been speculating about this interstellar medium for the past few decades. Together, the twin spacecraft Voyager 1 and 2 have now spent more than 40 years exploring space. Initially, their primary goal was to investigate Jupiter and Saturn. It was really just a quick mission. NASA built 2 probes extremely fast in the mid-1970s to take advantage of this once-in-a-century opportunity to the outer planets because of a unique planetary constellation. Because Jupiter, Saturn, Uranus, and Neptune's positions during the late 1970s and early 1980s only happened once every 175 years, it was possible to launch probes very far using very little fuel during this rare opportunity. The path was designed to allow the probes to gain additional momentum through gravitational maneuvers on each of the 2 past planets. This cut the trip time to Neptune from 30 to only 12 years. In the summer of 1977, Voyager 1 and 2 were hastily built and launched into space from Cape Canaveral spaceport. NASA was concerned that these 2 probes might not even make it to their initial target, given that they were meant to survive 5 years. NASA thought of expanding the 2-planet project to 4 planets shortly after launch, because the 2 probes performed their task so well and flew so flawlessly. With over 10,000 possible routes for Voyager 1's trip around Jupiter, NASA decided to go near to the moon Io. Titan was selected as an additional target for the orbit around Saturn. Voyager 2 was deemed suitable to continue its journey to Uranus following its successful exploration of Saturn. In order to deliver Voyager 2 to Neptune as soon as possible, NASA had already planned the Uranus flyby and applied for additional money to continue the project. On January 24, 1986, Voyager 2 arrived at pale blue Uranus, took its first images, and studied its magnetic field, delicate rings, and moons. Already, Voyager 1 was en route to the solar system's outermost point. This probe's second mission goal was similarly very clear. It was to reach the heliopause. There are many unanswered scientific riddles surrounding this mystical line that marks the beginning of interstellar space and the edge of the Sun's magnetic influence. On August 25, 1989, Voyager 2, just 3.5 years after the first mission to Uranus, arrived at Neptune. For the first time, scientists could see the magnificent deep blue gas giant up close. The probe measured exceptionally high winds on the surface, discovered a sizable dark region resembling Jupiter's red spot, and discovered remarkable geological activity on Neptune. We now know that Neptune has storms that are unlike any other place in the solar system. In the meantime, Voyager 1 was traveling around 35 degrees above the ecliptic plane and getting closer to the heliopause at a speed of about 520 million kilometers per h. At the conclusion of its journey to Neptune, the probe passed into the outermost region of the solar system on August 25, 2012. At a speed of 470 million kilometers per year, Voyager 2 likewise reached the end of the solar system by following a path that was around 48 degrees above the ecliptic. Its speed was marginally slower than that of its identical sibling. The probes monitored their surroundings, checked for particles, and located UV radiation sources during the flight. NASA declared, following the main mission's conclusion, that over 775 unknown objects, features, and planets had been found, photographed, and investigated by both probes during the flyby. Interstellar space is the great enigma of the universe. Can you image a space that spans billions of kilometers between individual stars and most likely has no beginning or end? The intergalactic medium welcomes you. The majority of the cosmos is made up of this space. It appears to be a blank, black void that is just existing. However, scientists are aware that approach cannot account for everything. Information abounds in this region, as do the remnants of burst stars, and it's quite probable that the interstellar medium also holds the structures that enable or maintain the cosmos. Exploring the amazing universe far beyond the solar system's edge and the sun's sphere of influence is the goal of the Voyager interstellar mission. The trip over the heliopause boundary, the outer bounds of the sun's magnetic field, was essentially the start of this extended mission. Penetrating the heliopause limit allowed scientists to measure the solar wind at its furthest edge and study its interactions with the interstellar medium for the first time. This is where the solar wind meets the forces and radiation of interstellar space. Our solar system is traveling across interstellar space at a breakneck speed. It is neither stationary in the cosmos nor contained within a galaxy. Scientists aim to study fields, particles, and waves at the frontier of our solar system, but they also hope to learn more about the dynamics of the solar system's motion within the galaxy and the cosmos. These days, we may categorize the probe's journey into 3 stages: the entry and exploration of interstellar space, the heliopause exploration, and the termination shock. At first, the magnetic field of the sun still affected the surroundings, which were dominated by plasma flows from the solar winds. The termination shock, where the solar wind slows from supersonic to subsonic speeds and significant changes in plasma flow direction and magnetic field orientation take place, was the first indication of the transition into interstellar space. The heliopause exploration phase started after the termination shock phase, which marked the conclusion of the transit through the termination shock. The outermost layer of the bubble the sun creates around itself with its winds is known as the heliopause. Solar winds and particle streams are the constant streams of plasma from the sun that flow across the entire solar system. The heliosphere, a protective ball created by these currents, envelops the sun and its planets. The magnetic field of the sun and solar wind particles continue to dominate the heliopause, the outermost layer of this protective sphere. The heliopause was reached by Voyager 1 in December 2004 and by Voyager 2 in August 2007. Interstellar space is starting to emerge in this region as the sun's impact diminishes. Voyager 1 eventually broke through the heliopause and entered interstellar space on August 25, 2012. The probe was the first artificial object to pass beyond this barrier as a result. Voyager 1 was roughly 122 astronomical units, or 18 billion kilometers, away from the sun at that point. The heliopause abruptly ending, as if from one instant to the next, startled the experts. They had previously believed that the heliopause was gradually blending into the interstellar medium. However, it appears that at this moment, the pressures from space and the solar winds combine to build something akin to a wall. On November 5, 2018, Voyager 2 crossed the heliopause into interstellar space at a completely different place and produced similar measurement results. This indicates that the solar system's unusually solid edge is most likely the same everywhere. In the interplanetary medium, excitement. Voyager 1 has gathered an abundance of information in interstellar space that has already fundamentally altered our view of space. The distance between the stars is denser than anticipated, according to measurements of plasma waves in interstellar space. There, the ionized gas-rich plasma serves as a useful proxy for the interstellar medium's general dynamics and activity. The observations revealed that the interstellar plasma has a density of around 0.05 particles per cubic centimeter, which is higher than that of the solar system's outer regions. This indicates that interstellar space is thicker than the heliopause. Once more, researchers were shocked by this, as no one had anticipated it. Additionally, the probe examined the cosmic ray strength in interstellar space, and it was found to be substantially higher than in the vicinity of Earth. High-energy particles from diverse origins around the universe make up these rays. It's highly likely that the radiation from these particles would be lethal to anyone on Earth. Therefore, the only reason life is conceivable for us is because our star covers us with a shield of solar plasma streams to protect us. NASA experienced a great deal of excitement in 2021. Scientists momentarily believed that Voyager 1 had gone insane or had been taken over by aliens because of strange data coming from the probe's attitude, articulation, and control system. Voyager 1's position in space is determined by the AACS, a system of gyroscopes and star sensors that allow it to navigate safely. Surprisingly, the whole object remained precisely aligned, despite the data indicating that the probe had lost its spatial orientation. The antenna on Voyager 1 is constantly facing Earth, and this has not changed. Hence, the probe was not rotating and it was not out of alignment. They said that Voyager had lost its position, yet the data kept coming in safely. It took several weeks to determine the cause of this misconception. The engineers eventually located the mistake. Despite the probe being on course, the onboard computer system appeared to have switched on its own, producing confused location data. Once the issue was fixed, Voyager 1 was able to continue flying through the interstellar medium without any problems. Until at least 2025, the Voyagers have adequate fuel and electricity to run their primary scientific instruments. Voyager 1 will be roughly 22.1 billion kilometers away from the Sun at that point. And after 1.6 light-years, Voyager 1 will arrive to the star AC plus 79 3,888 in the Giraffe constellation in almost 40,000 years. The best videos are still to come, so hit the subscribe button now.